Good evening, everyone. My name is Niketa, and I am the TA for the course Industrial Wastewater Treatment. So, this is an NPTEL course, and here we are in week 9 live session. So, what we do in this live session is I'll give you a brief overview of some topics that you have seen in this week's lectures, and following which there will be a question and answer session. So if you have any doubts, you can ask me anytime or in the end of the class. Okay, so do you have any questions from this week's lectures or from any of the previous week lectures? Okay, so since there are no questions, let's proceed. So this week we just have seen about the textile industry. So the textile industry is one of the largest consumer of water. So what they do here is they take the raw material, which is synthetic fiber or natural fiber, convert it into a cloth, and then dye that cloth. So all of this is very water intensive. It involves so many processes which will use a lot of water, and it will also generate equal amounts of pollutants. So, for example, if there is dyeing process, then obviously there is going to be dye wastewater. Now, dye wastewater is especially harmful because it contains a lot of persistent dyes or persistent compounds which don't degrade easily. So once it is generated, it's very difficult to degrade the dye. And even though we send this wastewater to a treatment facility, it is generally not effective for dyes because in conventional treatment processes we use biological treatment. So biological treatment involves treatment using bacteria. It can be either aerobic or anaerobic. So both of these processes are ineffective at treating dyes, and most of the time, like 40-50% of the dye will come out as such. And in the treated water, there will be dye. So along with the treated water, if we are disposing it, then we will be disposing the dye as well. So if we are disposing in land or maybe in a river or a lake system, so which is going to be a drinking water source, then it's a problem because along with the treated wastewater, we are also throwing off the dye into the drinking water source. So that's why it is important to follow proper treatment procedure. And yeah, we'll be looking at what happens in a dye industry and the processes, treatment processes that are followed. So most of these dyes are persistent, and one category of dyes exists known as azo dyes. So these azo dyes have nitrogen bonds, which are like very strong ones because it's a triple bond. So it is very difficult to degrade this, and even if it degrades, some of these dyes which contain this azo bond will form amines or other harmful substances even after the bond is broken. So, because of all these reasons, dye waste, textile wastewater is a problem, and treating it requires following proper, destructive procedures like advanced oxidation processes. Okay, so let's look at the processes of textile manufacturing. So there are two kinds. The first one is the dry process, which includes spinning, and the second one is the wet process. So the dry process is just spinning, like making it into threads, turning the fiber into threads and spinning it. So looking at the wet process, the first one is slashing. So in slashing, we add starch, and here the wastewater that is generated is slightly lesser. So minimal amount of wastewater is generated. And the second process is scouring and desizing. So here in the previous process, starch was added, and in this process, the starch will be removed. So when starch is removed, that will come along with the wastewater, because if you are removing it, then it will come as waste. So this step involves starch removal. And here we'll also add some alkaline substances like caustic soda and soda ash and even detergents. So all of these are added, and here this process produces 50% of the pollution that happens during textile manufacturing. Third process is bleaching. So can someone tell why bleaching is done? Why is bleaching done? It's very simple, right? What does bleaching mean? Why do we put bleach? So bleaching is color removal. And why do we do it to textiles? Because textiles fibers have natural color, so that needs to go before we can put dyes. So that's why we do bleaching. So bleaching removes the natural color, and that is done using peroxide. Normally, hydrogen peroxide is used. So it is a very good oxidizing agent and a bleaching agent. And also we use hypochlorite. So these two chemicals are used, and obviously in the bleaching process, when these chemicals are used, they will also come along with the wastewater. So that also contributes to the pollution. And the next one is mercerizing. So in this process, we treat the textile with 20% caustic soda. And this produces highly alkaline wastewater. Then the next process is dyeing. So this process is like, as the name suggests, involves infusing dye into the textile. And normally we use azo containing dyes. Like I said, azo dyes are those which have this N bonding, NN bonding, nitrogen bonding. So examples include component. So this is a very popular textile dye, but its usage in the textile industry has been discontinued because it's a well-known carcinogen. So its usage has been discontinued, but there exist other dyes as well which have the same azo bonding. So with azo bonds, these dyes become practically indestructible. So if we have to, break down the bonds, then we have to ensure that they go through this advanced oxidation process or some other effective and strong process which can break down the bonds. And also, we have to ensure that after breaking, it doesn't form any intermediates which are harmful. So that is the main concern here, because even though this compound will not exist, its intermediates can still be around. So these intermediates are equally or if not more harmful. So that's why it's important to ensure complete mineralization. So what does complete mineralization mean? It means ensuring that whatever organic pollutant we have is broken down into simple molecules like carbon dioxide and water. And if there are any sulfur compounds, then they are oxidized to sulfur dioxide or trioxides. And maybe if there are any nitrates, nitrogen-containing compounds, they are converted to nitrates and nitrites. So this is what it means. So whatever organic pollutant is there, it is converted into something which is inorganic and less harmful. So even though CO2 is produced, but it's still not going to be in the drinking water. It's an air pollutant, like any organic matter. When it degrades, it will produce CO2, including our body. So animal as well as human body, even plant bodies, as they decay, they will tend to produce CO2. So the concern here is ensuring that we achieve complete mineralization or complete degradation, which means turning the organic compound into mineral inorganic substances. Okay, so yeah, and another concern with having dye wastewater is that it makes drinking water look anesthetic. So nobody prefers drinking their water which is colored, right? Nobody wants to drink, orange colored or muddy or blue colored water because it's just anesthetic and unappealing. So that is another reason. And also, if the concentration of the dye is high, sometimes what happens is it can disrupt sunlight. So sunlight may not be allowed to penetrate because of the, uh, you know, because the dye concentration is very high. So that's why there is like the water appears very dark, and through dark waters, sunlight cannot penetrate. And if that doesn't happen, then small organisms which rely on sunlight, like planktons, so they are autotrophs. So they will not get sunlight for photosynthesis, and that could cause ecological destruction. So, yeah, these are the reasons why we need to ensure that dye wastewater is completely treated. Okay, now coming to the next process, it is finishing. So, finishing is the final step. Once we dye, we will add some chemicals to ensure that there is the appearance of the fabric gets better and it appears more polished. And the pollutants that are generated in this process include heavy metals, So heavy metals come from the chemicals used in the processing, and also if there are any like metal complexes, then they will also give rise to heavy metals. So, and then coming to the pollutants that are generated in textile industries. Normally, these are the pollutants that are found in the textile wastewater. They include heavy metals again, because most dyes tend to have heavy metals in them. So they are metal complex dyes. And then there are resins, waxes, and starch. Starch, like we've already seen in the second step, in the first step, starch is used, so that also comes here. That is also a pollutant. And chemicals like formaldehyde, silicon, etc. Okay. So, because of all these chemicals and pollutants, textile wastewater is generally classified as hazardous. So it is totally unsafe for consumption, and it should be properly treated before it is let out into the environment. Any questions so far? Okay. All right, so let's look at wool production. So, wool production, as the name suggests, uh, includes processing wool and then processing the raw hide. And because it generally comes from animals, so it will tend to contain a lot of organic impurities or pollutants. It's just how we saw in the hide industry or the leather industry. Raw hides generally contain some flesh and some fat, so which needs to be removed before the hide is taken for further treatment, for the processing. So similarly here, the raw wool that we get from sheep tends to have some organic matter attached to it, so that needs to be removed first. So that's the first step of wool production. First step is scouring. So this involves removing impurities and dissolving grease. So whatever organic matter is there, it involves removing them. And the next one is carbonizing. So here, concentrated acids convert any vegetable matter into charged particles. So here, carbonizing means adding some concentrated acids. And then the next step is bleaching and dyeing. So, bleaching and dyeing can be done at various stages. And finally, we add oil to it to make it spinnable, because generally wool fibers tend to be rough and they cannot be spun so easily. So that's why we have to use some oiling. So, yeah. And bleaching is done to remove any natural color if present, so that the color binds to the fiber uh, in a better way. And then the next step is fulling. So fulling means like even after weaving, the wool cloth, the wool fabric may not be very tightly bound. It could be uh, quite loose. So fulling involves shrinking the wool fibers into a tightly woven cloth. So basically, it means bringing the fibers closer together and making sure the weave is tight. So this process is shrinking the wool. Tightening. Okay, so the wastewater that is produced in woolen processing industries tends to be more alkaline with a pH of 9 to 10.5, and having a very high BOD or biochemical oxygen demand, and a high amount of total solids. So these are the this is why wastewater from woolen textile industry requires treatment, because it has a very high BOD as well as total solids. Okay, let's look at the treatment methods. First one is coagulation and flocculation. So you've already seen what coagulation and flocculation means, right? So can someone explain what it is? So this has been already covered in this course.
In coagulation and population, suspended solids and impurities can be removed.
Yeah. So what is used in this process? How these solids are removed?
For coagulation, we can use alum,
Yeah. Alum and iron salts. So all these are called coagulants. So once these coagulants are used, what happens next? What happens when the coagulants are added into water? So, what's the next step?
It's mixing and then mix hormone charge.
Yeah, so during coagulation, what happens to those suspended solids? How does the coagulant help? What does the coagulant do?
Can you repeat now?
Yeah, so what does the coagulant do? We add coagulants, but like what is the role of the coagulant? What is its function? What happens after the coagulant is added?
To remove impurities and solids.
Yeah, so how?
We add alum and then it will be mixing
Yeah, so
and
there's
neutralize
a,
negative charge.
you're right, but like there's a chemical process that happens right after the coagulant is added. So can you name that process? Like what exactly happens after the coagulant is added and how the colloidal particles get removed? So first, uh, like you have to think why the suspended particles remain suspended, right? So that is because of stable charge. So these particles all have the same charge, and particles with the same charge tend to repel each other. So after adding coagulants, what happens? What happens once we add the coagulant? So I just mentioned that these suspended particles they have the same charge, and because of that they tend to repel each other. So how does adding a coagulant, uh, you know, disturb this? So like, I think you must have seen maybe in week 3 or week 4 lectures about this term called charge destabilization. So basically, what happens is once we add the coagulant tends to form a layer of opposite charge over the particle, and because of that, it tends to bring various suspended particles together. So once they are like opposite charges, they tend to attract each other. So the particles then come together and form a flock. So basically, a flock is a slightly bigger aggregation of particles. So instead of having one individual particle whose weight is very less, and because of that it remains floating or suspended in the solution, we are bringing together like maybe a couple of more particles together, and because of that the weight increases, the size also increases, and then we mix the solution so that that helps in bringing together more particles. So the weight increases further, and then we finally allow the particles to settle down. So when we give that time, whatever flocks have formed, they will tend to come down slowly and settle at the bottom. And hence, these suspended solids can be removed completely. So that's the process. So this has two terms, coagulation and flocculation. So coagulation is what we've just seen, adding coagulants like alum and so on, so that the charge becomes destabilized, and then mixing the solution. So flocculation is basically mixing, gentle mixing, not a very fast one. So gentle mixing ensures that the flocks or the particles come together, closer together, so that they become proper flocks, and then they settle down easily. Okay. So the next process is adsorption. So you've already seen what adsorption is. So can you tell me what this means?
Adsorption is a physicochemical process to removing impurities and
Yeah, it is a physico-chemical process, but so is absorption. What's the difference between absorption and adsorption? Both are physico-chemical processes. There's a minor difference between the two. So can you point out the difference? What's the difference between absorption and adsorption?
absorption deals with surface adhesion and adsorption is deal with surface highly bulky volume.
Okay, so in simple terms, adsorption is a surface phenomena. This happens on the surface. This happens in the bulk. So what this means is uh, there are two kinds of substances, absorbents as well as adsorbents. So adsorbents tend to absorb the pollutants on the surface, like for example, there are some pollutants here, so these are just absorbed on the surface and they don't come down generally. They are only on the surface. But in the case of absorbents, so here the pollutants tend to come inside. So this is the bulk of the material, and they also travel through the entire material. So simple example would be a sponge. So a sponge is a simple example which is used for absorbing water. So another example could be chalk and ink. So yeah, so all of these tend to make sure the pollutant. In all of these processes, the pollutant travels inside the bulk of the substance rather than just remaining on the surface. So that doesn't happen in case of adsorption. In adsorption, it remains only on the surface. It doesn't come all the way in. So a very good example of an adsorbent will be activated carbon. So this is normally used in water filters also. So at home, if you have any water filter, then chances are that you could be having activated carbon in it. So activated carbon is used in water filters to remove VOCs or volatile organic compounds, and also sometimes even some dissolved gases like CO2, etc. So this tends to absorb really well, and it can even absorb any organic pollutant which, if present in the water, even in trace amounts. So yeah, it's about adsorption. Then coming to electrocoagulation. So here, this is very similar to coagulation that we saw earlier, but the only difference is instead of adding any coagulant, here we will be putting some electrodes. So we have the anode and the cathode. So these are positively and negatively charged. So this connecting it into to a power supply. We'll be connecting it to a power supply. So this ensures that an electrochemical reaction takes place, and because of the electrochemical reaction, the pollutant will tend to form colloids. So there will be some flock formation. So that is electrocoagulation, and once that happens, it will settle down at the bottom. And then we have reverse osmosis. So what is reverse osmosis? What is reverse osmosis?
On reverse osmosis is high pressure it's goes to low concentration to high concentrate to low concentrate. See,
High to low is what happens in osmosis. So when we have a substance of high concentration on one side, it will tend to go like if we have salt water here, and we have some unsalted or regular water. So what happens is the salt will tend to so the salt will tend to travel through the membrane and reach the other side, because here the concentration is high and here the concentration is low. So this creates a concentration gradient, because of which the salt will tend to flow to the other side. But in reverse osmosis, we apply pressure to ensure that the reverse happens. That is, we have a membrane, and here we have some regular water or low concentration water, and here we have salt water, and whatever salts are here, trace amounts or even mild amounts. So generally here the salt concentration will be much higher, and the tendency is to flow through this direction, from the high concentration to low concentration. But what we do here is we apply some pressure on the membrane, and we make sure that whatever salt is present in the low concentration side all tends to flow through. So salt from here will tend to flow through and come to the high concentration side. So this is the reverse osmosis process, and because of this, we need to make sure that there is a high pressure maintained on this side. Okay, coming to nanofiltration. What is nanofiltration?
Is used to remove organic pollutants or water supply. The pore size is between 1 to 10 nanometers.
Yeah. So,
It's basically used for pre-treatment.
okay, so which has a bigger pore size, nanofiltration or reverse osmosis?
Nanofiltration. Nanofiltration pore size is 1 to 10 nanometer.
Okay. And for RO?
For RO, we use a semi-permeable membrane. So the pore size is very
So, in nanofiltration, it is in the nanometer range, that is 1 to 10 nanometers. But in case of reverse osmosis, the pore size is even smaller. So it is about zero point 0.1 nanometers. So that's why it is even more effective at removing even ions. So yeah, that's the difference between the two. Basically, they operate in the same way. Pressure is applied here also, and yeah. Okay, these are the treatment methods which are used for uh, woolen wastewater or wool processing wastewater. So initially, before going through all these processes, like the BOD is removed by adding chemicals, like by doing coagulation. So whatever organics are there, they are present as suspended organics, so they can be easily removed using alum or iron salts like FeSO4, ferrous sulfate, and FeCl3, ferric chloride. So whatever suspended organics are there, they are removed using the coagulation process. And once they are removed, we go for a regular treatment like how we do domestic wastewater. So similar treatment process is followed using what are the conventional treatment processes that we have seen in this course? What are the biological treatment processes that we've seen in this course?
Ma'am, can you repeat the question?
My question is, what are the biological treatment processes that we have seen so far in this course?
What are the parameters?
Biological treatment processes.
Aerobic process
Yeah,
or anaerobic process?
aerobic and anaerobic. So can you name some processes under aerobic and anaerobic?
In a aerobic process, activated sludge process, tickling process,
Okay, and
tickling process,
yeah, trickling, and then
and anaerobic process, mm,
so we also have
respiratory.
lagoons, aerated lagoons, and we have oxidation ponds, and we also have sequential batch reactors or SBR. So all of these are aerobic processes. And anaerobic,
Anaerobic digestion, static tank,
yeah, anaerobic digestion, septic tank, and then we also have upflow anaerobic sludge blanket or UASB. So all of these are anaerobic processes. Good. And so this was about natural fibers. Now coming to synthetic fibers. So synthetic fibers use chemical intensive processes for their manufacturing. And typically synthetic textile wastewater has low alkalinity, high total solids, high organic nitrogen, a higher chemical oxygen demand, and a lower biochemical oxygen demand. So the treatment of this synthetic wastewater first involves diluting it with domestic wastewater. The reason behind this is because the COD is high and domestic wastewater will have a higher BOD. So to balance it out, we are diluting it with domestic wastewater. So first step involves dilution and the second step is aeration. So the treatment process first involves dilution. and then aeration. Okay, so one example of a synthetic fiber is rayon. So rayon manufacturing first involves shredding the wood pulp, and then treatment with 18% caustic soda, and adding alkaline, whatever alkaline cellulose is there from the first step. So that is added with carbon disulfide. And then the next step involves dissolving this in 6 to 7% caustic soda.
Ma'am, what is the third step?
Yeah, sorry, there was some minor interruption. Okay, coming back. Treatment or dissolving in 6 to 7% caustic soda. So this will produce viscose. And the last step uh, involves spinning. So spinning the fiber to make the cloth. And the wastewater that comes from this rayon manufacturing is can be divided into two parts. The wastewater. The first part is acidic. So this comes from yarn washing, cooling water, and mix in bucket. And the second type is alkaline. So the alkaline wastewater comes from using caustic soda and also from the desulfurization process.
Ma'am, your voice is not clear.
So the second type of wastewater is alkaline. So the alkaline wastewater comes from caustic soda as well as the desulfurization process. Okay, so if we don't treat the wastewater that comes from rayon manufacturing and we dispose it directly into any water source, then what happens is that it, since the wastewater contains chemicals like sodium thiosulfate and hydrogen sulfide, so these compounds are highly toxic to aquatic life and they can endanger the fishes or any other living organisms. And also, if we dispose it directly, there is a high chance that both acidic as well as the alkaline wastewater could mix up, and if that happens, then there will be precipitation because of salt formation, and that could also create sludge and other issues. So that's why we have to give a proper treatment before disposal. And also during the treatment, it is important to recover whatever resources we can from the process, because otherwise we tend to we have to buy the chemicals over and over again. Instead, if we were able to recover those chemicals during treatment, then we can recycle it and reuse it instead of buying a fresh batch of chemicals and then disposing them uh, along with the wastewater. So that's complete waste, and also it also pollutes the environment. So that's why we have to recover the resources wherever possible. So in this wastewater, we can recover soda, sodium sulfate, and metals like zinc. And once these are recovered, so the remaining rayon waste is treated using physical, chemical, and biological processes. Now let's look at the challenges that come during the treatment of the rayon containing wastewater. The first one is sludge disposal. And the second one is connected to the first one, which is land requirement. Now, since this contains a lot of acidic and alkaline wastewater, so during treatment it is highly possible that precipitation happens, and because of that, sludge may get produced. So the sludge needs to be treated properly. By treatment, we've already seen that goes dewatering, conditioning, and all that. And finally, the sludge needs to be dried in drying beds. So if we have to dry the sludge, then we need a land area for drying for having drying beds. So if that is not there, then we have to purchase land. So yeah, only if there is any large land area, this can be treated. Otherwise, it's very difficult. Okay. So now we come to the fertilizer industry. So fertilizers are of different types. Phosphatic, nitrogenous, and potassium containing. So let's look at nitrogenous fertilizer waste. Okay, so nitrogenous fertilizer. Usually, fertilizers are either phosphatic or nitrogen based or potassium based. So, coming to nitrogen based fertilizer. So, nitrogen based fertilizer can have a high amount of ammonia and urea. So the waste that comes from these industries will be rich in ammonia and urea, and also the pH will be high because these substances are alkaline, and it could also have a high amount of suspended solids and carbonates, and also the process chemicals that are used, and the final fertilizer product also. So sometimes the fertilizer also get dissolved into the wastewater and then it comes out, and it could also contain some oil bearing waste. So yeah, that's about the nitrogenous industry. So the problem with phosphate producing industry is that phosphate fertilizer industry, phosphatic fertilizer industries. The problem with these industries are that they produce fluoride containing wastes. So if the fluoride content in drinking water is high, then it could lead to teeth mottling, teeth decay, and so on. So that's better to avoid it. And again, the wastewater that comes from the phosphatic industry contains a mix of ammonia, urea, and even phosphoric acid. So, if we do not treat the wastewater and dump it as such, it could lead to the death of aquatic life and cause eutrophication. So, what is eutrophication? What is eutrophication? What is eutrophication?
Eutrophication is a primarily nitrogen and phosphorus in coastal water like lake, river.
Okay. And what happens because of that?
What no?
What
Causes
happens? So you're correct. Like it means adding nitrogen, phosphorus, and potassium containing yeast into our bodies. But what will be the effect of that?
it's leading to fish kills and dead zone.
Okay, but can you explain how the fish die? What happens once the nitrogen, phosphorus, or nutrient-rich wastewater comes into contact with aquatic life?
And what is the question exactly?
So the question is, what is eutrophication? You are partially correct. You said when nutrient-rich water, wastewater is dumped into drinking water or maybe a lake or a river.
Yeah.
Yeah. So what my question is, what happens after that? After dumping the waste, what happens?
Oh, uh, there will be the night the dump in the river like block the sunlight. Then the fishes and
But
fish.
why is sunlight blocked?
Uh,
Okay, so what happens is when we add nutrient containing wastewater, which is nutrient rich, goes into lakes. So the lakes could be having so the lakes could be having aquatic plants. So these aquatic plants, because they get nutrients, so they grow, and uh, like once they start growing, so imagine these are some aquatic plants, and because of that there will be some overgrowth. So this is the lake that we are considering. So imagine there is some overgrowth, and there are fishes too. So so the fishes are not allowed to grow because the plants are taking up so much space, and eventually what happens, whatever sunlight is there, that gets blocked because they tend to overgrow and their leaves grow so much, they tend to interconnect and they form a dense network. So this prevents any sunlight from entering into the lake. So like I said previously, if there is no sunlight, planktons die. Now, by planktons, I mean the photoplanktons, which produce their own food, like plants, by taking energy from sunlight. And if planktons die, so some fishes, some small fishes directly eat planktons, so they die. So if there are no planktons, then there are no small fishes. And if small fishes die, then the big fishes die too. So this is like a chain reaction. So because of the overgrowth, there will be no sunlight, and if there's no sunlight, then there will be no growth of planktons, and if planktons are not there, then small fishes will die, and because of that, the other fishes and the entire aquatic ecosystem will be disturbed. Right. Okay. So coming back to the phosphate fertilizer industry, the fluoride and the phosphorus can be removed using a two-stage liming process. And if there is any ammonia, then that is removed using air stripping. And if we are going for aerobic if we are going for biological treatment, then in biological treatment, ammonia gets converted to nitrate. Using under aerobic conditions. Using the nitrifying bacteria. And then this nitrate will be converted to nitrogen, like nitrogen gas. Right, so this is the first step called nitrification. So removing ammonia or removing nitrogen is a two-step process. Second step is denitrification. So denitrification the nitrification involves just conversion of ammonia to nitrate, and for the denitrification, whatever nitrate is there, so that will be converted to atmospheric nitrogen. And this happens in anaerobic conditions. In the presence of denitrifying bacteria. Right. So with this, we have come to the end of this live session. Do you have any questions from today?
No, ma'am.
Okay, so if there are no questions, then we'll end this session now. Okay, thank you for joining.